Welcome to Schweitzer Drive, a podcast where we explore what goes on between the generation of electricity and the light switch. Join Dave Whitehead as he interviews the entrepreneurs, innovators, and experts who are inventing the future of electric power.
Hi, I'm Dave Whitehead, your host for Schweitzer Drive. According to the U.S. Bureau of Labor Statistics, STEM jobs have grown 79% in the last 3 decades and are projected to increase another 11% from 2020 to 2030. How about that? Which begs the question, who will fill these roles? Today, I'm sitting down with Laura Harris and Caden Perry, 2 bright students who are among those closing the gap and helping invent the future of STEM. Laura recently graduated from the Running Start program at Spokane Falls Community College with her associate's degree and will attend the University of Idaho in the fall. Caden recently graduated from Moscow High School and will attend Georgia Tech. They've both been interning in the manufacturing division here at SEL and have joined the show today to share what excites them about STEM and what it's like to be young up-and-comers in the field. Laura, Caden, thanks for being here.
Of course.
Thanks for having us.
Oh, this is going to be fun. So, first thing, why STEM?
For me, it started when I was pretty young. I started building Legos when I was around 3-4 years old. And
not eating them?
Yeah, hopefully not eating them.
Okay.
Minimal eating Legos. And over time, I just came to love Legos. And that was the first job that I wanted from when I was like 4. I wanted to be a Lego designer. I just wanted to do that for the rest of my life. And
to actually design the Legos or just put them together?
Well, to design the sets, to use the ones that have already been designed, putting them together, building up sets, and then working for Lego doing that. But then over time, my dad's a mechanical engineer, and I came to see more and more things in the engineering field, flew on a couple airplanes, and kind of loved to fly, and really wanted to get into that field as well.
So as long as you can remember, you wanted to do something in STEM.
Yeah.
That's interesting. Laura?
I think what sparked my interest first was growing up watching documentaries on TV about bridges or rockets or computers and seeing the advances that we're making. And I really wanted to solve those kind of problems. And also both my grandfathers were very good with their hands in building solutions for people. So I really grew up with whenever you see a problem, you think about what you could create. And then joining robotics kind of solidified that's what I love to do.
That is really interesting. See, I kind of took a different path. I always thought I was going to be a lawyer since I was a little kid, and I loved arguing. Hell, I still love arguing, right? It's a lot of fun to do. But I had a physics professor my senior year in high school, and that was the tipping point. I took that class. I said, I want to be an engineer when I graduate and go on to college and stuff. What's it like being a STEM intern, and what types of problems do you work on?
So I've joined SEL in our product support and development mechanical group. And what we were working on is really pushing the boundaries of automation within SEL, working with collaborative robots in the space on the assembly line and designing fixtures and programs to actually assemble entire SEL products to hopefully free up assemblers to do other work that's maybe a little bit more challenging for them, a little bit less tedious, less likely to cause injuries.
Excellent.
I'm working in process improvement right now in U.S. panels manufacturing, and I get to work with engineers and project managers in the production floor and really find out how their workflow works, and then I get to create the solutions to help that workflow go better and grow as the company expands.
What's one of your favorite solutions you've come up with?
Right now I'm working with items in the warehouse that we don't quite know where they should go, and so I'm getting to actively clear those off and see in real time the difference I'm making and making sure we know where everything is supposed to be at.
That's really cool. And did you work on the cobots down in Lewiston?
Yeah, I've worked on designing all the fixtures and stuff for the ones that are released to the floor. That's really cool.
I saw some prototypes up here in the Pullman facility. And yeah, it's interesting. You talk about the cobots, and I agree with you. It's not that we'll be replacing labor with these things. Rather, we'll allow our folks to do more important things than just the repetitive work of, say, building an Axion module or what have you. This question's for you, Caden. I saw you recently won the Best in Fair award at the Northern Idaho Science and Engineering Fair for your work on refining drone design to increase efficiency. Congratulations on that. I'd love to hear more about that project. What did it entail?
So that project's been a couple of years in the works. I started last year on it when I heard about science fairs. And what I was trying to do is find a way to increase drone flight times. I started flying FPV, which is first-person view drones, a couple of years ago. And really one of the main barriers to use of drones in general and a lot of applications is flight time. You get to fly just a little bit longer. You can go out further. You can inspect different things that you couldn't previously. So I started thinking about helicopters. They have a large propeller that's a little bit more efficient. And then I used that in the center of the drone just to simulate getting a little bit more efficiency out of it. And then I used 3 smaller outer propellers just to control the stability and motion of the drone. So this is a project that started last year. I ended up winning Best in Fair last year. I went to Atlanta for the International Fair. And this year, after being in Atlanta, I saw the types of projects that are there, and I really wanted to make a step up. So this year, I spent a year just refining the drone, building 3 different prototypes, one of them being around 30 grams, another one, I think it was around 140, and then 180 grams, all of which are foldable, extremely compact, and working towards a final product. And so I'm working through the patent process and getting everything all patented.
Wow, that's really, really impressive. Now, these ground-up designs, it's not you take a kit and you modify it. Rather, you're printing stuff yourself, I guess, and finding motors and battery packs and what have you.
It was a big learning process. I mean, it was going like building entire carbon fiber frames, designing them, and then actually built the CNC router in my garage cutting carbon fiber. Usually it's not great for your lungs, so I tried cutting a little bit underwater.
Oh, yeah?
Yeah.
This is, you're quite the entrepreneur. This could be like a startup company or something.
That's the hope.
Wow, that's awesome. I've heard you both been involved in FIRST Robotics, which is said to combine the excitement of sports with the rigor of science and technology. What's your experience with this program been like?
FIRST has really changed my life. What
does FIRST stand for?
So FIRST stands for Inspiration and Recognition of Science and Technology.
Okay.
And it's the nation's leading youth STEM nonprofit, but it's a global organization.
Oh, wow.
And it changed a lot of things for me because I came in to learn how to code. And I learned how to code, but I also learned how to give presentations, how to apply for grants, and how to create a robot. And it also gave me a great family and support network based in the values of gracious professionalism. And so combining those skills with knowing how to use them and having that support has given me a really good launching pad from which I can take those skills into the real world, into my career.
You guys are making me feel bad about myself. It's like, man, I'm an underachiever at this point. You guys are really impressive. Let me ask you this question. You guys are knocking out of the park when it comes to STEM activities. Why doesn't everybody want to do this? Why are you guys so unique and special? And not that other people aren't special. That's going to come off all wrong. But you know what I mean? It is. Why do you guys like STEM? And yet we just saw the statistics, right? Where we're going to have a huge gap in folks that can invent, design, create, build, test, inspect, all of those fun things that we all love.
I think a lot of youth see it as unapproachable. I know when we go to demonstrations, we'll take this giant 120-pound robot, and they don't see that as something that they can work towards and achieve.
Why do you think that is?
I think because they're only seeing the finished product, and they're not seeing all the times we failed and all the things we had to learn and all the iterations we worked through to get there, because they can follow the same process and get there. But they're only seeing what took us months to prepare.
And so when we have new students coming into the robotics team, they're looking at our robot from last year. Like, how in the world are we going to reach that level? And seniors, we usually work through and we teach them little by little. We break it down. So we have maybe an arm subassembly and a shooter subassembly and an intake subassembly. And we just throw them at it. We say, try things. Take some plywood and cut it up, put some wheels on it, see what works, see what doesn't. And you kind of end up getting an idea of what the final robot's going to be just from those initial prototypes.
And that's how I really got brought in, was there were some seniors on the team when I joined that said, hey, you don't know a whole lot yet, but you're going to get there. We're going to guide you and help you get there.
Did you ever think about quitting?
No.
No?
I came in pretty early and fell in love. First meeting I went to, never stopped. And then I've won an award for my leadership and stuff. And so now I'm trying to give that kind of inspiration back in to the next generation of those students.
Oh, that's great. If you were trying to recruit, bring on other kids, how young would you try to convince them to join, say, your robotics group, or what would you do to entice them? And more importantly, what would you do to keep them?
Our team starts with 8th grade, but there is FIRST and other opportunities for as young as kindergarten. And I really say you need to show them the real thing. we're teaching you real skills that you can go and solve a problem with. And even when we take stuff to preschoolers, kindergartners, if they're solving a challenge, they're much more motivated to stick with it and find the next problem than if we're just giving them a kit to do that doesn't have much purpose.
And so all those kits and stuff, they build up over the course of, if you start in the program in middle school. I didn't start until my sophomore year of high school. And I really got started learning SolidWorks and 3D printing through robotics. And that's led me to doing things here at SCL that are quite fascinating and leading edge in the field.
That's great. What about, I've heard an obstacle that may keep kids or young people from going into STEM is all the math and the science that you have to take. Do you think that's an obstacle necessarily, or something that's easily overcome?
I think it's fairly easily overcomable. I mean, a lot of people, they look at the math and stuff and it doesn't make sense, but designing isn't all about math. You don't need to do all the hand calculations. There's a lot of software out there that does a lot of it for you. You just need to be creative. And it's more of an art engineering. You need to come up with solutions. It's a puzzle. And you just need to find a solution to the puzzle. You don't need to math the whole thing out. You just need to think about what would be a good way to solve some problem that exists, which is something a lot of people do and they might not realize it.
And you don't have to go to 4-year college. You don't have to take calculus to work in this field. You can solve problems at whatever level of academic education suits you. And there's lots of paths for different kinds of learners. So if that's the obstacle, there's another route.
That's really interesting. I was up touring up in our manufacturing up in the machine shop, and we've got a lot of capabilities with new CNC machines. We have mold makers and what have you. And those are some great STEM careers that didn't necessarily require a 4-year degree at a university. Rather, we created some programs, created some apprenticeships for folks to go through, and now these people are solving some really, really interesting and cool engineering problems. It's so much fun to see people create a mold or all the other new products we're putting up there. So that is a very, very good point. Not everybody needs to or probably should go to college, but yet there's still tons and tons of really cool high-tech jobs that we all need filled. What are you guys looking forward to when you go to college? What's got you the most excited?
I'm most excited for the engineering design capstone I'll get to do my senior year, because I've been going to that expo since I was like 9. And so that's really a big part of why I'm going to University of Idaho.
What's your project?
But you don't find out.
Oh, you don't know?
Your senior year. But just getting to apply what you spent years learning in college to an actual industry project, which I'm getting to do here, but also getting to show that at that expo is what I'm most excited for.
That's excellent.
I'm really looking forward to all the research opportunities and clubs that are at Georgia Tech. They're having a lot of vertical flight research opportunities. So I could jump in as an undergrad into one of those positions and look into how to push the envelope of flight efficiency and aircraft design further.
And which degree you're going after?
Aerospace engineering.
Aerospace. And you?
Computer engineering.
Computer engineering. Again, I'm jealous because we didn't have quite all those cool things when I was going to school. What advice would you guys give me to be able to recruit younger people or get younger people interested in STEM? And what age do you think it is? You're talking about being 3 years old and playing with Legos. I don't know if I can barge into somebody's living room with their 3-year-old. I'd probably get arrested or something like that. But what advice could you give me?
I don't think you're ever too young to be interested in solving problems and creating solutions. And I think giving students a real problem to create a solution to is really the key to getting them engaged, at least for me. And I think for a lot of people that we work with is if you give them a real challenge and the skills and then step back and then let them be creative and let them design what they think might solve the problem.
And as far as SCL specifically, their high school internships are hard to come by. They aren't really publicized. It's hard to find out that there are high school internship opportunities here at SCL. And so maybe if SCL were to reach out to people that are maybe winning awards in the community, different people that appear in the newspaper, different leaders in the community, to tell them, hey, we do have high school internship opportunities. We do have opportunities here. Here, come check us out. We aren't guaranteeing you a job, but we exist.
How do you guys find out about these jobs?
I was wandering around at the University of Idaho Career Fair and just handing out my resume to a bunch of people. And my resume eventually ended up on Jonathan Richards' desk, and my dad had lunch with Jonathan Richards that same day, and then he asked me in for a tour, and then eventually I got hired.
Oh, excellent. How about you?
I got in through our mentor, Ben Herman.
Uh-huh.
He found out I was interested in SEL and asked for my resume and got me an interview.
Wow. That's a great story. All right, here's a good one. Where do you guys see yourselves in 10 years with your STEM careers? What would you want to be doing?
I think I want to be ideally in the middle of a startup company working on vertical flight research. I mean, there's a lot of flying cars and stuff out there, a lot of companies just starting up in that field, and there's still a lot of room for improvement, both on the air traffic control side and on the design side, to get to the point where they're actually usable.
I was looking at a company that has, I don't know, I think it's vertical takeoff, but it's got like four fans in it, right? And it's it's kind of like a motorcycle with 4 fans on it, right? That you'd go right around. And I was looking at the range because I was seeing if I could make it from here to Coeur d'Alene Lake, and I'm just shy, I think. I'd crash like in Tico or something like that is where I'd come down. So that's something you got to work on is the range.
I think I want to be working with a group of interdisciplinary engineers and on projects that aren't just within the scope of one field of engineering or one type of problem, but ones that really are more complex in nature. And I love the coordination between lots of different people and helping them reach their full potential and together as a group, creating those solutions.
You're going to be a program manager when you grow up, aren't you?
I'm working with them right now. So.
Oh, that's one of the hardest engineering jobs. Try to get 4 engineers to work in the same direction. That's always the challenge right there.
And that's what robotics has given me a lot of experience in, because I basically project managed the last several years.
That's so incredible. Again, you guys are making me feel like an underachiever. It's you guys are going to knock it out of the park. Do you guys have any questions for me?
I think what do you want to see most out of the future of those STEM jobs, your future employees?
I think you sort of nailed it on the head in that I think the first thing you really want to have out of somebody that you're working with or somebody that's working for you, right, is this curiosity, right? How does this work? How can I make it better? What problem should we be solving, right? And if you have that kind of curiosity, the world is your oyster, if you will, right? It's this innate desire to go solve a problem and figure stuff out. And I am never the smartest person sitting at the table by any means, but I always have this: how are we going to go do this? How are we going to solve this, right? And it always drives you to get people to work together to go solve a problem, or go scratch your head and say, how else can we solve this problem? And I think that's really what has always got me excited about the STEM fields, right? It's this solving problems. Somebody's missing something, and if we can come along and help, close the gap or come up with a new solution, there's nothing more rewarding. People ask me, what do you think is rewarding? And every time I walk into a substation, I see a relay that I helped design or another product I helped, and somebody thought so much of whatever we came up with that they'd actually pay money for it, install it to solve one of their problems. That is, is this the engineering thing or STEM that we're talking about? That to me is really one of the most, rewarding things we can do. Well, thank you all for taking some time out of your day to talk about STEM, and I'm going to follow your all's careers. And again, when I'm working for you, please be nice to me. Remember what fun we had today. So thank you.
Yeah, no problem. It's been a pleasure.
Thank you.
Thank you for stopping by Schweitzer Drive. Join us again as we learn about, explore, and celebrate electric power. For more information about the show, please visit selinc.com/Schweitzer Drive.